I'll first of all show you guys, right, the Docker based approach, right? That how does the Docker based Kubernetes approach works. Now, let's say that, if you already have here a Docker installed, right? We have a Docker desktop and things installed. Now, in my extensions, here from the extensions, I can download the extension for Kubernetes. Okay, I can download the extension for Kubernetes. That is like either this dive into Kubernetes, or let's match the official ones. So this is the one, like this is known as Lens, right? Lens for your Docker desktop. So we already have Lens with us. The Lens is nothing, this Lens looks like this, okay? This is a Kubernetes IDE. This is a Kubernetes IDE, like you have a Visual Studio Code, okay? Like you have a Python PyCharm IDE, like you have a Eclipse for Java. So likewise, we have a Kubernetes IDE known as a Lens, okay? This is very helpful where, because you have to, you can set this up, you can just create the things here in a easy way. Easy way in terms of that you can see all the UI form of the deployment pods, whatever the Kubernetes objects we wanna install that. But let's say that we will go with some of the approach known as Docker Lab. This thing, the if we install this here, let's say how it works. Okay, so once we have this extension and these things will be installed, so you can access the Kubernetes, you will get the Kubernetes and those things here, and you can use that thing here. But again, our point was not going to be that. Okay, we are not going to use, or we are not going to install the things using this. Now, another thing is that you can have the mini cube. Okay, so you can have the mini cube here. Mini cube is again a single node cluster. It is what? It is a single node cluster which you can install, in your local machine. Okay, in your local machine means in your normal local laptop. So this says, we all saw that in the yesterday session in architecture, that Kubernetes has a master nodes and a worker node, right? And it can have more than one worker nodes. But Minikube says what? That you set up everything on one, okay, and you can run this thing on a local, for a local development testing, for a local stuff, you can use the Minikube. So this way, Minikube is a single node cluster which has master and worker node in all one only, and you can just install Minikube in your local machine, and you can do Minikube start, and you can start using the Minikube. This will be our last thing to look into that. Okay. Before all of these things, we will also look into the other one that is known as AWS one. Okay, as we are already using AWS for everything, so we will be using AWS one for our purpose. Under the Amazon EKS service, okay, this causes us only 10 cents per hour. That means if we use it for 5 to 6 hours, it will cost you around 100 INR, okay, which is pretty much okay for all of us. The other option we have is that we can install this cluster known as scale up, like any cluster you can set up by just creating a cluster. So you can say that, okay, you have a cluster here. So let's do it together. Okay, I'll delete this cluster, let's say. Okay, let this cluster be there for now. I can create one more cluster. Now, as soon as you click here, you will click on the custom configuration. So recently, with the EKS, they have launched EKS Auto Mode, which basically allows you to quickly create the cluster by it has chooses on its own default settings and things. But when we are creating a cluster, as we saw the different components yesterday, right? You have a kube proxy, you have a metric servers in add-ons, you have a scheduler, you have the HCD, right? You have a lot of different components, architecture things of the Kubernetes. So it's important to have a configuration as a custom part and see if your cluster is you are able to run the cluster in the right way or not. So every one of you, please open your EKS and come over to this particular screen. Give me a thumbs up once you are over this page. So once we are here, okay, so let's do this thing. Let's click on create cluster. Let's click on custom configurations and disable the EKS auto mode. Give any name of the cluster, okay? Let's say that we give the name as cluster 1, okay? Whatever the name you want to give. Now you have to create a role, okay? You have to create a role, but we don't know that what cluster role we have to create. So click on this create recommended role, and this will take you to the new page. This is the what? This is the IAM role, right? Which is basically needed so that it can talk to different services. So you will here just select the trusted and like keep this as a default. Okay, keep this as a default. Don't make any changes here. Just see that it is going to talk to EKS service, okay, as a EKS cluster. Click on next. It is already giving itself a cluster policy. This is going to be used for the internal purpose, and all this cluster policy and things will be here. Again, we'll click on next. You give the role name, okay. So let's say that you give the role name as role hyphen one, and let everything be like that, and just click on create role. Okay, so let's just give the role name and let's just click on create role. As soon as you have clicked on create role, if you will refresh here, you will see that role. Just select that role from there. Let the Kubernetes version to be 1.33 only. We have a latest version also known as 1.34, but let it be at 1.33. Kubernetes releases almost every 3 to 6 months, some minor to major versions. Now, once you are done with that, keep the other settings default. If you see the other settings, it says that do you want a standard support or do you want the extended support? Let's keep the standard support. That means the Kubernetes support or AWS support which we will be getting for the 14 months. Okay, for the extended support means you get the support for the 26 months after the release date. Okay, this is something which you get after the release date. Then it says that do you want to give the IAM privilege permissions or not? So yes, we want to give the IAM privilege permissions. Okay, and here just choose this EKS API and config map. Okay, just choose this, the EKS API and config map. Now once you have this being set, right, let the other settings remain same. Click on next. Let it be as a default VPC. Okay, and this cluster endpoint access should be public and private both, because we want to access it from the outside our VPC. When we are working within the organizations and things, then we also select it as a private, because we want to connect it within our VPCs only. Okay, you can have this advanced setting also. You can select the endpoint CIDR block. Right now we are giving access to everything, so we are giving that. In the observability section, don't select anything, just click on next. And these add-ons, remember yesterday we talked about the add-ons, right? The core DNS service, Amazon VPC, Kube proxy, all this comes under the add-on service of this. So let the default add-ons be selected. Let the default add-ons be selected, and you keep going on with next, next, next. And as soon as you have done with all of the next, just click on create. Now your cluster creation might take from 5 to 8 minutes. Okay, it can take from 5 to 8 minutes to create the cluster. So let's wait until the cluster is getting into the creating state, from the creating to created state. So let's wait for that. Now, but meanwhile, if you see, this was one of my cluster which I have created with the same approach. Okay. Now, if you will see this, right? So you will see that the cluster is active with the Kubernetes version 1.33 installed. EKS is a provider because we are using Amazon EKS service, right? And when you see, it will have a lot of different details, right? It will create a certificate for itself. It will have a OIDC provider, right? It will have the cluster IAM role, ARN, and platform, and these things. We'll talk about all of these things. EKS auto mode we have disabled, and we have like not selected other settings. But this resources is something from where you can view the things. Okay, you can view the steps, like you have a pod, you have a replica set, deployment, jobs and other things. All of these things you can see it running here itself. Before we come to that, as soon as we create a cluster, so cluster is what? It is one simple thing, right? Which basically says that, hey, I have created a cluster, name as scale up with Sachin, and that cluster has some nodes. That cluster will be having some node group. How will you do that? You have to first of all manage the nodes. So for that, we created a node group. Okay, we will be creating a node group in which you will be saying, or you will be deciding that based on your requirement, based on the things, what capacity of a cluster you need. Okay, how much big, how much small your cluster you need, right? Do you need a cluster with 2 node access? Do you need a cluster with 4 node access, right? What should be the desired size? What should be the minimum number of nodes in there? Okay, you can have multiple node groups. Example, you create one node group, okay, name as a, let's say, skill Sachin. Another node group you create skill Sachin 1. Now this node group skill Sachin might require the instance with a smaller size, that is M7I large, M7I large. There would be other node group which was going to spin up a bigger instances. Okay, so accordingly we go ahead and we check that whether the node groups, we define in the node groups that what kind of nodes, what kind of EC2 instances we need. These nodes are nothing, these are my EC2 instances only. Okay, now this status of this node group or node should be always ready state, okay, or active state. If it is not good, the status is not healthy, your pods will continuously restart. Your pods will continuously restarting, okay? And not one, whatever number of pods a particular node can run, all of those will continuously restart. Now, in the networking, you have all the VPC and all the subnet related settings, okay? Which right now we have given the full permissions. In the add-ons, right, in the add-ons is nothing, this is our different add-ons which we have installed, okay, for kube proxy to ensure that networking happens in a right way. VPC CNI, this is one of a pod networking driver, okay, or you can say pod networking category, right? Likewise, you have the core DNS, which is helpful for the service discovery. Remember, we talked about the dynamic EC2 policies and things yesterday, so it is about the same thing. So you can always upgrade the versions, upgrade the things of your add-ons and things from here. Access, this is again important part because this helps you to give the access. Okay, this helps you to create the access, create the pod identity and other things. Okay, observability, you can set up some Prometheus metrics, CloudWatch and other things, but we don't want it to do with this way, so we have not done that. This will tell you the update history. Likewise, if you're gonna upgrade it from 1.3 to 1.34, so all those update history will be coming here. And this you can create the tags so that you can filter out the things. Now, as soon as your EKS cluster is spin up, as soon as the things are spin up, okay, this is very easy way to spin up with the EKS. Okay, you don't have to install manually anything, so everything is already set up. You will see that by default, you have kube system namespace, kube public namespace, kube node lease, external DNS, and the default namespace. These are the 5 namespaces which are by default. What are namespaces in Kubernetes? Namespaces is nothing but it is one of the isolated component, you can say, okay, which creates an isolation between the different layers. For example, we are 5 people, we can create a 5 different namespaces so that your work will be in your namespace, mine work will be in mine namespace, right? Let's say that Moin work will be in Moin namespace. Okay, so the namespace does what, it just gives you the isolation. Now, every application, every system and other things are responsible to run up in a particular namespace. For example, we see this kube system, right? We see this kube system. This has AWS node, core DNS, node monitoring agent, kube proxy, and metric servers. Means whatever my add-ons were there, all these were what? These were add-ons. So whatever my add-ons were there, all of those have been installed or all of those have been set up where? Under the kube system namespace. Does that make sense? All of these things are under the kube system namespace, the add-ons which we have installed. Kube public. Kube public doesn't have any pod right now. This was a default namespace just it has created. Likewise, kube node these also doesn't have anything. And external DNS has the external DNS service, okay? Because we are making it a public and other public endpoint, so it might have to connect to some public endpoint, right? So that's why we have the external DNS. And in a default namespace also there is nothing. Default is a namespace which will be created by default. Now you can always you cannot go ahead and edit the things from here, right? But you can always go ahead and you can always, let's say in the kube system namespace, you want to check this pod. So okay, this pod is in a running state. This is installed as a daemon set. We'll talk about all of these things in a separate. Now you see that on which node it is running. Okay, you can see the node on which it is running. What are the two containers it is running? So these are the two AWS containers which it is running. Okay, these are the two AWS containers which it is running, right? And there is also one init container being initialized with this. What are the labels being attached to this manifest? Any events, anything? You can see only these informations. And if you click on raw view, you can see the pod manifest. This is the YAML. These are the code which we gonna write, which we gonna see. Okay. So this is how you can just view the things on this. Okay, you can't perform or you can't do the actions on the stuff. You can see the deployments. Okay, you can see the other things. Now, important part. If you see this cluster, right, in this cluster here, you can see the nodes, that how many nodes are installed and whether it is ready or not. You have the namespaces, right? If any other services are running, you can see all of those things. Configuration, secrets. In this, you will have a config map. It stores the environment values and the other things. If any secrets are created, so it will store that. Okay. You will have the volumes, right? So volumes can be stored here. Okay. If you have any, the storage class, by default, we have a GP2 storage class. We also have CSI and other things. So if you install the EVS CSI driver, you can have that also. But to access this and these things, we can't do all the things from here, right? We have to install the things in the local also. Okay, we connect to the AWS config and other things, and we want to set up the things in the local. For example, I want to check the pod in the kube system namespace. So I will create the connection and I will just write the command kubectl get pod in which namespace I want -n kube system. So this will give me the pods which are running in this particular namespace. Okay. But this is one of the way. The other way is that I can also set up lens. Okay, this is my lens. In here, I can see everything. Now here, I don't have to run the commands. I can just go and click here, right? I can check the logs if I want. So I will click on this. This will show me the logs for the particular pod, right? Whatever the way I want to configure it. Now, how we gonna configure, how we gonna do all of these things?